Far in the depths of our solar system, beyond the orbit of Saturn and Neptune, lies an enigmatic world, Uranus. A planet that, despite its icy blue appearance and fascinating features, often fades into the background in the grand narrative of the cosmos. Yet, orbiting this distant giant is a system of rings that defies our expectations, delicate and faint, yet filled with profound complexity. These rings, though not as dramatic as those of Saturn, offer us a rare glimpse into the forces at play in the far reaches of our solar system. A system where ice, rock, and gravity come together in a silent dance, governed by the hidden rules of celestial mechanics. As we journey through these rings, we are not just exploring a distant world, but also peering into the heart of planetary evolution itself. Uranus is a planet that stands apart. It is tilted on its side, its axial tilt a staggering 98 degrees, unlike any other planet in our solar system. This unusual tilt affects everything about Uranus, from the way it spins to the way its rings appear. Viewed from Earth, the planet seems to be spinning on its side, giving the rings an almost edge-on perspective. Faint, fragile, and elusive, Uranus's rings can be difficult to observe from our vantage point, hidden in the glare of sunlight as it reflects off the icy particles that encircle the planet. This tilt is a key feature of Uranus, but it also makes its rings appear incredibly thin when viewed from Earth. In fact, the rings are so faint that, for many years, they were largely overlooked in favor of their more visible counterparts, like Saturn's iconic rings. And yet, Uranus's rings tell a different story. A story of hidden beauty and complex interactions waiting to be uncovered. These faint bands of rock and ice, barely detectable from afar, have long been a source of intrigue for astronomers, challenging us to ask, what do they tell us about the nature of this distant planet? And what can these rings teach us about the processes that shape planetary systems in the farthest reaches of space? It was only in 1977 that astronomers first discovered the faint ring system of Uranus, an observation made during a stellar occultation when the planet passed in front of a distant star. This unique event allowed astronomers to detect the subtle interruption caused by Uranus's rings, revealing their presence to the world for the first time. But it wasn't until the Voyager 2 spacecraft passed by Uranus in 1986 that we were able to see these rings up close. The spacecraft's detailed images, captured as it flew by the planet, revealed a series of narrow, icy rings, a complex and finely structured system that had remained hidden for centuries. The discovery was nothing short of remarkable, showing us that even the outermost planets have secrets worth exploring. The photographs sent back to Earth revealed something entirely new. Uranus's rings were not just faint bands of dust. They were complex, dynamic systems, some narrow and sharply defined, others more diffuse and scattered. These rings, with their muted tones and delicate structures, seemed almost fragile, yet they were far more intricate than we had ever imagined. It was as if Uranus, the distant giant, was hiding a secret, one that we had only just begun to unravel. What exactly are these rings made of? When we peer into their depths, we see an intricate mixture of particles, some as small as grains of sand, others as large as boulders. These particles, primarily composed of water ice, have a rough, dark surface that reflects little sunlight, making the rings appear faint and dim to the human eye. Yet, within this icy material lies a wealth of information about the forces that created them and the history of the planet itself. Uranus's rings come in two distinct varieties. The first are the narrow, brightly reflecting bands that appear tightly confined, with clearly defined edges. These rings are composed of particles that are relatively uniform in size, suggesting that they have been shaped by some external influence, such as the gravitational pull of a nearby moon. Then, there are the broader, more diffuse rings, made up of smaller particles that are scattered across a much larger area. These rings appear almost faint, their boundaries less well defined, and their particles more spread out. One of the most fascinating aspects of the ring system is its layered structure. The narrow, brighter rings are often separated by dark gaps, regions where there are fewer particles, or where the gravitational influence of a nearby moon has created a void. These gaps are a testament to the intricate dynamics of the system, where even a small moon can exert significant influence on the behavior of the particles that make up the rings. The gravitational forces at work here are delicate and precise. Each moon, each particle, playing a role in shaping the structure of the rings in ways we are still trying to fully understand. So, how did these rings come to be? The origin of Uranus's rings is still a subject of scientific debate, but one leading theory is that they formed from the debris of a moon or moons that were torn apart by the planet's powerful gravitational forces. Early in the planet's history, a moon could have wandered too close to Uranus, crossing the planet's Roche limit, the point at which tidal forces exceed the moon's self-gravity, causing it to break apart. The remnants of this moon would then have been captured by Uranus, eventually forming the rings we see today. This theory of tidal disruption could explain the varied and sometimes chaotic nature of the rings. After all, the violent process of moon shattering could result in a range of ring structures, some tightly packed, others more dispersed. And while this process may have happened billions of years ago, the rings are still evolving, their particles constantly colliding, shifting, and interacting with each other in an ever-changing cosmic dance. The dynamics of Uranus's rings are driven by the gravitational pull of the planet's moons, which act as shepherds of the particles within the rings. These moons, small as they may be, exert enough force to shape and contain the material in the rings. They guide the particles, keeping them confined within narrow bands or creating gaps in the rings. Some of Uranus's moons, like Miranda and Puck, are particularly important in this process. Their orbits create gravitational waves that influence the structure and stability of the rings, preventing them from spreading out into space or falling into the planet itself. These interactions are not static. The moon's gravitational forces cause the particles to shift, creating temporary features within the rings. Some areas may become denser, while others become sparse. And as these particles collide and interact with each other, the structure of the rings can change over time, making them dynamic rather than static. It's a delicate balance of forces, one that reveals the ongoing evolution of the ring system. Though not as spectacular as Saturn's rings, Uranus's rings provide us with invaluable insights into the nature of planetary ring systems. They offer clues about the processes of planetary formation, the mechanics of tidal disruption, and the interactions between moons and rings. By studying these faint rings, we can better understand how other planets, both in our solar system and in distant star systems, might form and evolve. The study of Uranus's rings isn't just about understanding this distant world. It's about using what we learn to expand our knowledge of planetary systems across the universe. Just as we study the rings of our own solar system's giants, we can apply these lessons to the discovery of exoplanets and their ring systems. Each discovery, each observation, brings us closer to answering fundamental questions about the processes that shape planets, moons, and rings throughout the cosmos. As we look toward the future of space exploration, the mystery of Uranus and its rings is far from solved. New missions, such as the possibility of sending another spacecraft to study the planet's icy rings in more detail, could reveal even more about their structure, their origin, and their role in the history of the solar system. The faint, distant rings of Uranus hold secrets waiting to be uncovered.